sensor, variable attenuator, frequency meter, slotted line carrier bridge, and detector, right? So I've already given you the explanation on the working of Klystron, right? We have electrons and repellers. So you should know this. We should keep this in amplitude modulation. Beam voltage should be at 200 volts, all right, and repeller voltage should be anywhere in between. Okay, if you go to 200 volts, then both ends of the Klystron are pressurizing each other, right? We don't want that situation. It will heat up very soon. So start by by taking at -6 or -12 or -20 or -50, wherever it gets, right? You will get at multiple points. Okay, and make sure that this is totally clear. I mean about 25. You don't get in attenuation from 25 to 10, but still. Okay. So as you put this in, 25 onward, this is in micrometer, alright? What you get inside is micrometer. Okay, fine. Now Klystron power supply, you can switch it on, wait for a few seconds, and then switch on this test, right? Then give it to beam voltage and put beam voltage to 200 volts. Then current should increase. Okay, till current increases, we cannot do anything. If there is something wrong, current will not increase. By the time your external happens, we would have changed this now. We already sent it for approval. Alright. So current, yeah. Now see, current is increasing. Okay. So current increases means you have electrons generation. I have already given you the diagram now, right? If you are still confused about it, you can Google it. You will get an IIT manual. Okay, IIT Kharagpur manual or something. There all components explanation. Okay, fine. So current, we have got it. So we'll switch it to repeller voltage. What are you doing? You'll get the explanation online.
They asked me today.
Who asked you today? Fine. So we have this repeller voltage now. What we have to do is we first of all see it's going to be very hard to get this square wave. Let's see, you've got a square wave. Okay. Now as we go on, as time passes on, the square wave will become better and better and better, since the electrons are generated are better. Now since the knob here is not good, we are not going to get a very good square wave. Okay. Now you will get the square wave at multiple points, -6, -20, -50, and multiple points of 110. Choose anyone. Okay. But initially you will get it at -6. So I have kept it at -6, right? So first of all, experiment is to find the frequency. So frequency meter, you can use to find frequency. What happens when I turn this?
Square wave compresses.
Yes, it'll get compressed. At that point, whatever is the reading on this scale is your frequency. Slotted line carrier bridge, we have to find the guided wavelength, right? Your equation should be there in your manuals or observations, right? That is D1 minus D2 minus D1, right? So that can be either maxima or minima, right? So what we do is we find the maxima. This is my maxima. Then this is the minimum. So what is the point over here? Take 3 values and choose 2 consecutive ones which will give you near to whatever you have got directly. So what happens over there is you're finding the slotted. See this. These are all waveguides, right? Waveguide, right? So the wave that travels in this, we are trying to find the wavelength of that wave. There's a difference between a wave that travels in a waveguide and the wave which travels in free space. Okay, one which travels in free space is governed by the law of F by lambda is equal to C by F, right? But whereas the guided wavelengths do not go by that law. So we have to convert it into free space wavelength, then go for frequency. That is the equations which are given over. Is that clear? Next, to find VSWR, we have to go for maximum. What is the voltage? And then minimum. See, VSWR is voltage standing wave ratio. What does it mean? It is incoming when your incoming wave, that is the input wave, is coming in. Whatever is reflected, the difference will be constant. So we'll have a constant wave, right? So it's called standing wave. So what is the ratio between maximum and minimum? Will give us the voltage standing wave ratio, like it shows over here, right? Maximum to minimum. So maximum is 360, minimum is 170, 180, right? 170. So 360 by 170, right? Ideally, VSWR should be, if they ask, ideally it should be 1. Okay, 1 means there is no standing wave. Maxima and minima are the same, right? But 1 we don't get. That is an ideal condition. So we look for anywhere between 1 to 1.5. Usually we'll get around 1.5 in the 1.4, right? We look for 1.1 to 1.5. In these cases, you are getting 2. Okay, right? After this, we are finding VSWR. You're going to connect this to VSWR meter. Can you give me that? I'll just show you without connection. Be careful when you pull this. Can you lift it? Right. So if you all can see this, we are going to take only 2 scales. We are going to use only 2 scales over here. The first scale is the SWR scale. The second one is the dB scale. Usually for your microwave reading and other things, you are using the dB scale, right? The SWR wave, that is the standing wave ratio scale, is used only to find the VSWR. So when you connect this, usually the procedure is you will connect this to VSWR. Then you are going to move to the maxima point. Once you move to the maxima point, all right, then suppose maxima point is over here. You can move either way. No need to go like this only or like this one. Either way, whichever you want. So your scale will be moving. When it goes and comes back, when it gives a kick back, that point is a VSWR. Remember, your scale is going to move like this. That is what kick back. When it's moving like this, it goes into kick back and then goes back. That is, you understood this? Your scale will be moving, right? Maxima to minima, maxima to minima. Wherever it gives a fluctuation, that is your VSWR, right? Then it is just attenuation. Whatever value you get in dB, that is your power rate in dB. You know how to take it, right? Then attenuation. So 25 is 25 micrometer, right? Not centimeter. Here it is in centimeter, but when it's here, this is the waveguide, and this is the place where your wave is going to travel in. I cannot have centimeters of attenuation to go in. Only micrometer will be inserted. You understand this? Right? So when I go from 25 to 20, that means it's 20 micrometer. 5 micrometer is inserted. It's not making any difference. 25 to 10 will not make any difference. Only from 10 onwards, you're going to get some difference. Okay, fine. All these details you can get in microwave textbook by Samuel Y. Leo. You can go one day, 1 hour is enough. Go have a look, make notes, study from it. What is a klystron? What is a isolator? Klystron you will get online. Isolator, variable attenuator. How does this isolator work? How does the variable attenuator work? Microwave frequency meter. How does it work? Slotted line carrier bridge. How does it work? All this part of your Viva. Okay.